June 6, 1944, the Normandy coast. Dawn hadn't fully broken yet, but the sea was already alive. Engines roared across the water as hundreds of landing craft surged forward through gray waves and mist. Inside each one, 36 soldiers stood packed tightly together, rifles clutched, shoulders pressed against steel walls, listening to the grinding diesel engine beneath their feet. No one spoke. Ahead of them was a coastline turned into a fortress, machine guns, artillery, barbed wire. And somewhere beyond that, the future of the war. This was the largest amphibious invasion in human history. Over 150,000 Allied troops committed to a single morning. 5 beaches, 1 chance, and everything depended on the boats carrying them. The boats themselves looked simple, too simple. A flat-bottomed steel hull, 36 feet long, 10 feet wide, a front ramp, and an engine that sounded like it belonged on a farm, not in war. Just a few years earlier, every U.S. Navy engineer who examined this design reached the same conclusion: it shouldn't work. The problems were obvious. A flat bottom makes a boat unstable in open water. Instead of cutting through waves, it slams into them, hard. Violent impacts that should shake the structure apart. In rough seas, it should be nearly uncontrollable. Then there was the ramp. That was worse. Every principle of naval architecture warned against it. Never open the front of a boat to the sea. The moment that ramp drops, water floods in, faster than any pump can remove it. The boat fills, loses buoyancy, and sinks. And yet, on this morning, more than 1,500 of these impossible boats were racing straight toward the most heavily defended coastline in Europe. Inside, the soldiers waited. Some stared forward, some looked down, some closed their eyes and tried not to think about what would happen in the next few seconds. Because when that ramp dropped, they wouldn't be climbing, they wouldn't be struggling through water. They would be running straight into fire. The boat hit the shallows. The engine cut. Momentum carried it forward until the hull scraped against sand. The ramp dropped and the soldiers moved. Not climbing, not waiting, running. 8 seconds to reach the waterline. 8 seconds before the machine guns found them. Without these boats, those 8 seconds wouldn't exist. Because before this design, landing on a defended beach looked very different. April 25, 1915, Gallipoli. British and ANZC forces attempted an amphibious landing against Turkish defenses. The boats stopped offshore. There was no ramp, no direct exit. Soldiers had to climb over the sides and drop into the water, chest deep, carrying 60 pounds of equipment. Then they had to move forward through resistance that slowed every step. 45 seconds. That's how long it took to reach the beach. 45 seconds of exposure. 45 seconds as a perfect target. The Turkish machine guns opened fire from elevated positions. Clear line of sight. No obstacles. Men fell instantly. Some were hit before they even touched the water. Others drowned, dragged under by their own equipment, unable to move, unable to fight. The sea turned into a killing zone. The campaign lasted 9 months, more than 250,000 Allied casualties, and one brutal lesson learned. You cannot land troops under fire by forcing them into the water. For the next 2 decades, military planners tried to solve it. Different designs, different ideas, rope ladders, cargo nets, side exits. None of them worked, because the problem wasn't the method, it was physics. A soldier in water can't move fast, can't take cover, can't fight. The obvious solution was simple. Put a ramp on the front, let them run straight onto land. But every engineer said the same thing: impossible. Water would flood the boat, the hull would weaken, the ramp would jam, the structure would fail under stress. Every report ended the same way. The idea worked in theory, but in real combat, it would fail. Then, in early 1941, a Marine officer heard about a man in Louisiana. Not an engineer, not part of the Navy, just a boat builder who worked in swamps. His name was Andrew Higgins. His boats weren't built for war. They were built for oil companies working in shallow marshes, places where water was measured in inches. His designs could run in water barely deep enough to cover the propeller. They could drive straight onto mud, unload cargo from the front, and reverse out without getting stuck. To most people, it was just a practical solution to a commercial problem. But to the Marine officer, it was something else entirely. Because if a boat could drive onto a swamp and unload from the front, it could drive onto a beach and do the same thing. And if it could do that under fire, it could change everything. He didn't go through official channels. That would take too long. The idea would die in paperwork. So he paid for the trip himself, got on a train, and went to New Orleans. He found Higgins at his boatyard, a 52-year-old man with no formal engineering education, who had built his first boat as a child and spent his life solving problems the Navy had never even considered. The Marine officer explained what he needed: a boat that could approach a hostile beach, drive onto sand, drop a front ramp, and let soldiers run forward instead of climb. Higgins listened, then pointed at one of his swamp boats. "This runs in water so shallow I can spit farther," he said. "Drive it onto mud, back it off, no problem." The officer asked the question every Navy engineer had rejected: "Can you put a ramp on the front?" Higgins didn't hesitate. "I can put a ramp on anything." 3 weeks later, the prototype arrived, and it looked exactly like what every engineer feared: a steel box, with a crude ramp bolted onto the front, like someone had welded a barn door onto a boat. And according to every expert in the Navy, it should have failed.
The prototype didn't look like a revolution. It looked rough. The welds were uneven. The ramp was a flat steel plate hanging on simple hinges, raised and lowered by a cable and pulley system that looked more improvised than engineered. It didn't resemble anything the Navy had ever approved. In fact, it looked like exactly the kind of design the Navy had spent years rejecting. The Bureau of Ships reviewed it first. They produced a detailed report, 12 pages long, outlining every reason the boat would fail. Water would pour over the ramp and flood the interior. The hinge system would jam with sand and salt. The flat bottom would make it unstable in anything but calm water. And most importantly, the man behind it had no formal training in naval architecture. The conclusion was clear. The design represented a fundamental misunderstanding of how boats worked. The Marine Corps read the report. Then they ignored it, because there was only one way to know. They took the boat to New River, North Carolina, and prepared to test it under conditions as close to combat as possible. Rough water, live fire, obstacles placed deliberately in its path. If the design was going to fail, this would expose it. The coxswain pushed the throttle forward. The engine growled as the boat surged ahead. The flat bottom slammed against the waves, each impact sending vibrations through the hull. It wasn't smooth, it wasn't comfortable, but it held together. The shoreline approached fast. 10 yards out, the throttle cut. The boat slid forward, riding its own momentum, then ground onto the sand. The ramp dropped. 36 Marines charged forward. They hit dry sand. Total time? 18 seconds. They ran it again. 17 seconds. Again, 19. By the end of 3 days, they had run 23 separate tests. The ramp jammed twice. Both times it was fixed in seconds. The hull held. The boat didn't swamp. It didn't sink. It did exactly what it was supposed to do. The Marines reached a conclusion the Navy had failed to see. This wasn't a flawed design. It was a breakthrough. They recommended immediate production. The Bureau of Ships pushed back again. Tests were controlled environments. Real combat would be different. The flaws would appear under pressure. The Navy shouldn't commit to an unproven design from an inexperienced builder. The debate continued through the summer of 1941. Then, December 7th happened. Pearl Harbor changed everything. The United States was now at war across 2 oceans, and the nature of that war made one thing clear. Every major objective in the Pacific required amphibious assault. Islands, beaches, fortified positions surrounded by water. Without a reliable way to land troops quickly and effectively, the entire strategy collapsed. There was no more time for debate. On December 15, 1941, the Navy placed an order: 1,000 landing craft, with an option for 20,000 more. The contract went to Andrew Higgins, with one condition: build them faster than anyone thought possible. Because now it wasn't about whether the design would work, it was about how fast it could be produced. January 1942, New Orleans. Higgins Industries was not prepared for this. A small company, a handful of workers, a few buildings. Traditional boat construction methods, skilled craftsmen shaping and fitting each piece by hand. At that pace, one boat might take a week. At that rate, building 20,000 boats would take centuries. Higgins didn't try to scale the old system.
He replaced it completely. Instead of craftsmen, he used a production line. Instead of custom work, he standardized everything. Every component was simplified. The hull was broken into prefabricated sections. The ramp used basic hinges and cables. No specialized parts, no complex mechanisms. If something could be made simpler, it was. He brought in unskilled labor and trained them for specific tasks. One worker cut steel, another welded, another assembled. No one built an entire boat. They built one part of many boats. The design allowed multiple factories to produce parts simultaneously. If one facility was hit, production continued elsewhere. It wasn't just efficient, it was resilient. The company exploded in size, from 75 employees to 20,000, from one building to 8 city blocks. Production ran 24 hours a day, 3 shifts, no stops. By mid-1943, the output was staggering. One boat every 23 minutes, 60 boats a day, hundreds every week. From raw steel to finished vessel in under 3 weeks. Quality control was simple. If it floated and the ramp worked, it shipped. Perfect welds didn't matter. Speed did. Because somewhere in the Pacific, men were waiting for those boats. By 1943, the Higgins boat, officially the LCVP, was ready for its first real test. Not a simulation, not a controlled trial. Combat. November 1943, Tarawa Atoll, a small island in the Pacific, heavily fortified, 3,000 Japanese defenders, bunkers, machine guns, artillery, everything positioned to stop a landing. The plan relied on naval bombardment to weaken defenses. It didn't work. Most of the Japanese positions survived intact. Then another problem appeared, a coral reef, running hundreds of yards offshore, too shallow for most landing craft, too deep for soldiers to move effectively. Some boats stopped at the reef. Marines climbed over the sides, dropped into the water, just like Gallipoli. Chest deep, slowed, exposed. The machine guns opened fire. Men fell. Some drowned. Some never reached the shore. But the Higgins boats kept moving. Their shallow draft allowed them to cross the reef. They reached the beach. The ramps dropped. And the Marines ran forward. Still under fire, still taking casualties, but moving, not trapped in the water. The battle lasted 76 hours, over 1,000 Marines killed. It was brutal. But without those boats, it would have been impossible. Tarawa proved one thing. The design worked, even in the worst conditions. 7 months later, it would face its greatest test, Normandy.
June 6, 1944. Normandy. More than 1,500 Higgins boats surged toward the beaches in the opening hours of the invasion. The sea was rough. Smoke filled the horizon. Naval guns thundered behind them. Aircraft roared overhead. And ahead, German defenses waited. Omaha Beach became the worst of it. Everything that could go wrong did. Bombing runs missed their targets. Naval bombardment failed to destroy key positions, and one of the most experienced German divisions, the 352nd Infantry, was exactly where it wasn't supposed to be. Machine guns were already trained on the shoreline. When the first wave approached, the boats didn't slow. They couldn't, because stopping meant death. The coxswains drove straight in, engines straining, waves crashing against flat steel hulls, bullets striking the water around them. Then the boats hit the sand, the ramps dropped, and the world exploded. Machine gun fire tore across the front of the boats. Some soldiers were hit before they could even step forward. Others made it off the ramp and into the chaos of the beach. Some boats took direct hits and sank before unloading. But the system worked. Men were getting off the boats. Not climbing, not waiting, running. Even if it was only a few steps, even if it was crawling, they were on the beach. And that changed everything. The difference was time. A soldier climbing over the side of a traditional landing craft into chest-deep water needed about 45 seconds to reach shore. 45 seconds under fire. 45 seconds exposed. Most didn't survive.
A soldier exiting a Higgins boat needed less than 10 seconds to reach the waterline and start moving forward. 10 seconds. That 30-second difference decided who lived and who died. Wave after wave kept coming. The boats didn't stop, even as the beach turned into a killing zone, even as casualties mounted. The system held. Men landed. Units formed. Positions were taken. Slowly, painfully, but steadily. By the end of the day, over 150,000 Allied troops were on French soil. The cost was heavy. Thousands killed, thousands wounded. But the beachheads held, and once they held, the invasion could continue. Within days, more troops, vehicles, and supplies poured in. Within weeks, Allied forces pushed inland. The liberation of Europe had begun. And in nearly every after-action report, one detail appeared again and again. The landing craft worked. After the war, General Dwight D. Eisenhower said something that stunned many people. He didn't credit a general, or an admiral, or a battle plan. He said, "Andrew Higgins is the man who won the war for us. Because without those boats, there is no D-Day. Without D-Day, there is no invasion of Western Europe. Without that invasion, the war takes a completely different path." And Andrew Higgins wasn't a military strategist. He wasn't an engineer trained in theory. He was a boat builder from Louisiana, a man who solved a problem because he didn't accept that it was impossible. The genius of the Higgins boat wasn't advanced technology. It was simplicity. It was understanding what actually mattered. The Navy had tried to design a perfect landing craft, one that handled well in open water, one that followed every principle, one that avoided every risk. Higgins asked a different question. What does the boat actually need to do? Not perfectly, just effectively. It didn't need to handle like a destroyer. It just needed to survive a short trip from ship to shore. The flat bottom that made it unstable in deep water became an advantage in shallow water. It allowed the boat to slide onto beaches, to cross reefs, to avoid getting stuck. The ramp didn't need to keep all water out. It just needed to work. Long enough to drop. Long enough for men to get off. By the time water became a problem, the mission was already complete. Even the tunnel stern, originally designed to protect propellers from swamp debris, proved essential. It allowed the boats to survive coral reefs, beach obstacles, hidden hazards. Nothing about the design was accidental, but none of it was originally intended for war. Between 1942 and 1945, Higgins Industries built over 20,000 of these boats, more landing craft than the rest of the world combined. They were used everywhere: North Africa, Italy, the Pacific, Normandy. And every time, the same result. Troops reached the shore faster. More of them survived. Estimates suggest the Higgins boat reduced amphibious casualties by nearly 50%. Tens of thousands of lives saved. Not by a weapon, not by armor, but by time. After the war, Higgins' company collapsed. His factories shut down. His name faded. The man Eisenhower credited with winning the war died in 1952, largely forgotten. But the design didn't disappear. Every modern amphibious landing craft still follows the same basic principle: flat bottom, front ramp, direct deployment. The idea that once violated every rule became the standard. Today you can still see one at the National World War II Museum in New Orleans. A restored Higgins boat. Steel hull, simple ramp, rough welds. Nothing elegant, nothing impressive at first glance. But that's the point. Because the story of the Higgins boat isn't about perfection. It's about what works. The Navy was right. The design had flaws. It was unstable. Water did come in. It did break the rules. But when those boats hit the beaches of Normandy, none of that mattered. What mattered was that the ramp dropped and the men ran forward. That's how wars are won. Not by perfect designs, by solutions that work when everything else fails.